All right, physics class, let's go through a few of these problems together. We are looking at projectile motion. We worked on free fall before, and this time we're looking at objects that are launched horizontally. So remember, we're looking at X and Y components here. This one says, tennis ball off the desk. Desk is a meter high, so if you were to draw that, you got this ball coming horizontally off of that. Obviously, it's going to drop to the ground. And the tennis ball is rolling off the desk at 1.6 meters per second. So you have the X component here. This time we do have an X component. We have a horizontal motion, and it's asking how long, so it's asking for time. This is simply a matter of, for horizontal, you have the velocity, horizontal, I'm going to put a little X there, for horizontal velocity is 1.6. And it is a meter tall, so that is a Y component. I'm just going to put a Y value here, it's 1 meter. And it's asking how long will it take for the tennis ball to hit the ground. Also, remember, for the Y component, you know the acceleration is negative 9.8 meters per second squared. And the initial velocity is 0. You want to find time. Remember, the time is the same for horizontal or Y component. It doesn't matter. So in this case, look and see what you're given and try to figure out which formula we're going to use to find time. So if I look at our formulas here, you are given everything you need to find time using this formula for the Y component. So I'm going to use the distance, or Y, the height. The height here equals the initial velocity times time, which is 0, so I don't need that component, I don't need that term, 1/2 AT squared. And now you're going to solve for time. So time here is going to equal the Y value, which is the height that's given to you, times 2. I'd multiply both sides by 2. And then I would divide by the A, and I would take the square root of that. So this is the same formula, but solve for T. So you plug in the Y value in the A, and you'll be able to find the time. Then, now we're going to use that time, over here in the X component. That X component is asking how far away from the desk is the tennis ball? Meaning, what is this distance? What is that X value? What is the distance? We've been calling it D, distance. Well, velocity equals distance divided by time, or distance is equal to velocity times time. So take your velocity, multiply by the time that you found over here, and you will get the correct answer. Okay? Number 8, a paintball is fired horizontally from a tower 45 meters above. So again, you are given the Y value here is 45. And it says the paintball gun fires at 90. So it's the same setup here. You are told that the horizontal velocity is 90. And again, you always know the vertical acceleration, the Y component of the acceleration is negative 9.8. And the initial velocity here horizontally is 0. This is exactly the same type of problem. You're going to find time. How long does it take? Find time using this formula, and I solve for T there for you. Plug in the Y value, the height, and the acceleration. Find your time. Then you're going to use that time over here, because velocity is equal to distance divided by time, or distance is equal to velocity times time, to find how far away. Okay? All right, number 9. Number 9 says, you and your friends build a confetti canyon to be used at VHS football games, whatever that is, another school maybe. We'll say Waukesha. You can adjust the initial firing speed of the cannon depending on how far away you want people to get showered with confetti. If the cannon is mounted at the top of the snack bar, so it's at a height. You want to hit the football team as they enter into the field, and they are 20 meters away. What speed does the cannon need to fire in order to properly shower the football team? So it's the same type of idea, but this time you're going to be finding the speed here. Let's just kind of draw an image or a diagram here. You're going to be launching stuff out of the cannon like that. That's the confetti being launched. So this is 7 meters high. You want to hit the football team as they enter into the field while they are 20 meters away from the cannon. So this is 20. Nice diagram, makes a big difference here. What speed? We want to find the speed that is going to be coming out of the cannon. Okay? So, again, we need to find the time, because if I want to find the speed, velocity is equal to distance divided by time. I have the horizontal distance, but I don't have time. So I'm going to find the time using the y component. The y value, the height here is 7 meters. The a acceleration, of course, is always negative 9.8. The initial velocity for the y component is 0. You're going to do exactly what we did above. You're going to find the time that it is in the air using the y component. Find the time here, then use that time over there in the y component along with the distance of 20 meters. Find that, put that time in there to find the velocity of the confetti coming out of the cannon. Okay? All right, this section here is dealing with angles. We're not going to get into that. But let's look at a few others on the other worksheet. So grab the other worksheet here that says projectile motion worksheet, and let's work through a couple of these. I'm just going to set them up for you. I'm going to walk you through them, talk you through them, and then you can finish them up. We're not doing the ones that deal with any angles. So we're not doing 6, 7, 8, 9, or 10. Stone is thrown horizontally. So you have an initial velocity. Of 8. From a cliff, 80 meters high, you have a y value. How far from the base of the cliff will the stone strike the ground? So you're going to need the time if you want to find distance, because distance is equal to velocity times time. And where are we going to get that distance? From over here. Negative 9.8. The initial y velocity is 0. And you're going to find time. You're going to use the same thing. Time is equal to the square root of 2 times the y value divided by the acceleration. Find your time, then you take your time and put it in there along with the initial velocity and x component, and find your distance. Okay? Moves off the table at 1.5. Okay, so this is giving you a y value. Table is a y value of 1.25, sorry. Car lands 0.4 meters, so it's giving you a distance. This is a horizontal distance here. How long did it take to hit the floor, and with what horizontal velocity was it moving? So I'm going to need time again. If you're given the height, ladies and gentlemen, if you're given the height of it, you can find out the time by using the acceleration and the initial velocity of 0 when there is horizontal launch, a horizontal launch. So same thing, time is equal to the square root of 2 times the height. I'm using y as the height. Find this time, then along with the distance, you can then find the horizontal velocity, because velocity is equal to distance divided by time. You're given the distance, the horizontal distance, you'll find the time from the vertical components and then put those in to find the velocity. Number 3, bald eagle in level flight at a height of, okay, again, you're given a height here. I'm going to call that y, 135 meters. Drops the fish it caught. If the eagle's speed is 25 meters per second, we're assuming that's horizontally. How far from the drop point will the fish land? We're trying to find distance. We're going to need time. So find the time from the height, the acceleration, negative 9.8, and the initial velocity, the y component is 0. Find the time using this. Find your time, then along with the velocity, you can then find the distance. Distance is equal to velocity times time. They gave you the horizontal velocity, you find time, then you can plug that in to find the distance. We have a horizontal launch here toward a target that is 120 meters away, but at the same height. Okay, so this is saying this time you're launching something horizontally and you're trying to hit a target that is 120 meters away. So the distance here is 120. But of course, the bullet is going to drop. The bullet's velocity is 200 meters per second. How far below the target does the bullet hit and how long did it take to get there? Basically, you're trying to find the height. You're trying to find the height. Imagine that this is the ground. It's not going to actually hit the ground. It's going to hit below the target, though. This is your target. And that target is 120 meters away from where you shoot it. The bullet is going 200 meters per second. You can find the time from now the x component. So this time we're going to use the x component to find the time. Just think about what you're given. Okay? You are given, in this case, the initial velocity and the distance that it travels horizontally. It travels 120 meters horizontally. So from that, I know that distance is equal to velocity times time, so time is equal to distance divided by velocity. You're going to take the distance, 120, divided by the velocity, 200, and that will give you the time. You now have the time. And then it says, how far below the target does the bullet hit? This time you're trying to find the y value. What is the height that it drops? You're trying to find the y value. To find the y value, then you need the equation that says initial velocity times time plus 1/2 at squared. Well, the initial velocity in the vertical direction is 0, so that term is gone. So it's just the 1/2 at squared. 1/2 at squared. You have your time from the horizontal. You're going to use that time there along with the acceleration. Don't forget to square the time to find the height that it drops. Okay? Okay, next one, number 5. It says, a bird traveling at 50 meters per second, you are given the x component of the velocity. Wants to hit a man 100 meters below with a dropping. That's weird. But 100 meters, that's your y. It's going to drop at 100 meters. How far in distance before flying directly over the man should the bird release it? In other words, you want to know how far is it going to travel horizontally. What is that distance going to be? D, you want to find distance, which means we need to find the time. Anytime you're given the height, the vertical height, you can find the time. time is going to equal the square root of 2 times the y is the height, over the a. You solve this, put in your y and your a is negative 9.8, and then, well, you can use 9.8, don't use negative because you can't take the square root of a negative, and then you just have your time, and then you're going to use that time over here to find the distance, because distance is equal to velocity times time. So you take your 50 times the time that you found over there. Okay? All right, those are some good problems on projectile motion when something is launched horizontally. If you got questions, please let me know.